Time for some math. Okay. If a water gun is fired in the air, the height of the water in meters after t seconds is given by the quadratic equation, which is shown here. But the equation of this is height equals negative 5t times t minus 20, displayed in the graph. Now remember that this is just the same as negative 5 is our a value. We have t minus 0 and t minus 20. Now, water gun is not a good example here. We might say a water fountain, a jet. Water jet might be better, and you'll see based on some of these numbers. So what are the x-intercepts of this quadratic relation? Well, again, it would be what would t, and these x-intercepts are really the t-intercepts because the x-axis is time. But what are the t-intercepts? What would the value of t need to be to make each bracket 0? So t would be 0, we see from there, and t would need to be 20, we see from there. So what are the x-intercepts or the t-intercepts? T equals 0 and t equals 20. And what do they actually mean in terms of this graph or this situation? Well, those are the actual time that the water was or is at a height of 0, right? Is at ground level. So the water fountain, the water jet is here. It sprays the water up. It goes up that high and then it comes down, and the whole thing takes 20 seconds from start to finish, from when it leaves the ground to when it comes back to the ground. Now the axis of symmetry again goes through the vertex, but if we needed to find it, we would add our two x-intercepts together and divide them by 2. 20 divided by 2 is 10, and that's 0 plus 20. 20 divided by 2. Hey, that makes sense. There it is. Now, what does that axis of symmetry actually mean in the context of the problem? So it means two things, really. It's the time at which the water reaches its maximum height, and it's also the point. It's where the water stops going up and starts coming down. Now what's the vertex? Again, we can see that that point there is 10, and when we take it across, it's halfway between 400 and 600, so it's 10, 500. The y value of the vertex, what does it mean in this context of this problem? Again, that's the maximum height reached by the water. So again, this is a very powerful jet. It's at ground level. It has a squirt of water, the water goes up, takes 10 seconds, and in that 10 seconds it eventually gets up to 500 meters above the ground, and then it comes back down, and it takes 10 seconds to come back, and it hits the ground. Now, that squirt in terms of height and time creates a parabola, but we don't care. This is a parabola that it matches, but really the real part of the graph, the actual real part, is when time starts to when the squirt of water hits the ground, unless it gets squirted at an angle and comes down over a cliff, comes down over a ledge, anything like that. So the real part of the graph is right there, unless there's other parts that stipulate the jet is actually sunk under the ground. So again, that's where the water is squirted, but then in terms of the height of the ground, there it is. Okay, so do another example. The arch of a concrete bridge is shaped like a parabola. The arch of the bridge is 3 meters high at the highest point. So again, that 3 meters high at the highest point is part of our vertex. The bridge is 10 meters wide at the bottom. So graph the bridge on the grid, assuming that the far left corner of the bridge is located at the origin and that the water is at ground level. So here's the water at ground level. We then have our bridge that starts at the origin, 10 meters wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's got to come down there, which means we need to find the vertex. Again, the vertex is going to be those x-intercepts, 0 and 10, all divided by 2. So that's our axis of symmetry, or halfway. And it's going to be up 3. And so our bridge is going to look something like this, from one end to the other, or maybe it'll have the same thing continue that way. The top of the bridge maybe is like that, maybe there's a railing. A road surface, a walkway, whatever. Again, I'm sure it goes down to the riverbank and actually hits the ground, and we have the water and the fishes and everything. So if we found the halfway, again, we found the vertex. There's its height, and there it is. So what is the vertex? 5, 3. And it's a point, so we have a comma, and it's in brackets. And what does it represent in the context of the problem? That is the highest point of the arch above the water, and where it occurs, how far out. What are the zeros? Zeros, remember, are our fancy words for x-intercepts or solutions. So what are they? X equals 0, and x equals, it told us, 10. What do they represent? They're where the bridge supports come back and actually touch the level of the water. And I'll call them arch. And they touch the water level. Now specifically in this one, the equation of this parabola, would the sign of A be positive or negative? So when we come back, we remember that an A value, if it's positive, the parabola opens up. If it's negative, a parabola opens down. So what do you think the A value of this curve, being a parabola, actually is? I would probably say it's negative. How do you know? Because the arch is over top. There's a maximum height, and it opens down. Yeah. Okay, flip the page. Let's do one more together. Ball is thrown from the ground and follows a parabolic shape modeled by the equation h equals negative t minus 2 squared plus 4, where h represents the height of the ball in feet, t represents the time traveled in seconds. At the same time, a flare is launched from a height of 4 feet and follows a straight path represented by the equation h equals negative t plus 4. Using the table of values, graph the path of the ball. Remember, strategically choose your x values based on the equation. So what do we see from there? Well, vertex form tells us the vertex. Remember, brackets lie. The default equation has a negative, so that vertex is 2, 4. So because I get to choose, I'm going to put it in the middle of my table. If I want to choose 2 points to the left and 2 points to the right, I'm going to have those points. Now I need to sub in when t is 1. So what's h equal when t is 1? Do some math. Negative 1 squared is positive 1. That negative in front is still there. Negative 1 plus 4 equals 3. Because this is a vertex, I know that this is going to be a mirror image. There's my axis of symmetry, so I know that that is 3 as well. Alright, let's solve for when t is 0. Negative 2 squared is 4 times negative 4 plus 4 is 0. So now I have my solutions, my y-intercepts. I have a maximum height, and I'm going to graph accordingly. I got to make the scale 0, 1, 2, 3, 4. Let's follow the same scale here. Again, on my x-axis I have time in seconds. On my y-axis I have height in feet. So can I graph this parabola? Absolutely. Take my x-intercepts, 0, 0, and 4, 0. I have my vertex, 2, 4. And I have my other points, 1, 3, and 3, 3. And I draw my parabola. Again, it would continue past, but I only care about the live or the real part, which is there. So there's my parabola drawn on the graph. Now on the same grid, I'm going to graph the flare without using a table of values. So remember that the flare equation is negative t plus 4. So state what I know. I have a y-intercept of 4. There's the flare. I have a slope of negative 1. That means down 1 to the right 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And I can graph my line. Again, my line would continue forever in both directions, but I only care about from when it's fired to when the flare hits the ground or is done. Now what are the solutions? Meaning, what are my answers? Where do these two lines cross? And they actually cross in 2 spots. There's 1 and there's 2. So one solution is 1, 3, and the other solution is 4, 0. What do these solutions mean in context of the problem? Those are the points where the flare would hit the ball if they were lined up. So on the way up, the flare would hit the ball. If they were off not straight at each other, the flare would come down, the ball would come down, and the flare would hit it. Okay, give those a try.